Hi, this is Wendy Lightheart, and in this video we are going to be learning how to solve problems, some word problems, but in particular some application problems that we can use rational equations and proportions to solve. So first we're going to look at motion problems. So recall that the formula for distance, d equals r times t, where d represents the distance one has traveled, r represents the rate of speed, and t represents the time traveled. Motion problems in which two distances are traveled in the same amount of time can be solved using a rational equation. Note that if we solve the above formula, the d equals rt formula, for time, so to do that you would have to divide both sides by r, you would obtain the equation or formula t equals d over r. This is the version of the formula we will use to solve these type of motion problems, the type of problems again where two distances are traveled in the same amount of time. So for this first example, we have a boat that can travel 10 miles downstream with the current, and the same boat can travel 6 miles upstream against the current in the same amount of time. If the rate of the current is 4 miles per hour, what is the boat's average rate in still water? Notice we see that phrase, in the same amount of time. So this is the type of problem that we can use a rational equation to solve the problem, and we're going to be using that version of the motion formula, t equals d over r. So when it says the same amount of time, in this particular problem it's telling us the time to travel downstream is equal to the time to travel upstream. So for each of these different times, or these same times, but the time downstream and the time upstream, we'll use the distance divided by rate formula to represent that time. So distance traveled downstream divided by rate of speed downstream would be the time to travel downstream. And similarly, distance traveled upstream divided by the rate of speed upstream will give us the time to travel upstream. And we are given the distance for each of these scenarios, and we just have to figure out an expression for the rate of speed downstream and the rate of speed upstream. So to do that, we're going to let b represent the unknown rate, which is the boat's average rate in still water. So this is the speed that the boat would be going if the current was not affecting the boat's speed. So let's think about going downstream with the current. How would the current affect the boat's speed? Well, if you're going with the current, the current's going to be pushing you faster, right? So how much faster? Well, it depends on how fast the current's going. Since in this case the current is going 4 miles an hour, the boat's speed is going to be increased by 4 miles an hour when it's going downstream with the current. So the expression b plus 4 would represent the boat's speed going downstream. And then if we think about going upstream, when you're going against the current is actually going to slow you down. So the boat would have been going b miles an hour in still water, but the current is slowing it down by 4 miles an hour. So b minus 4 would represent the boat's speed going upstream against the current. So those are the expressions we'll use for those two rate of speeds, or rates of speed. Okay, so now let's plug those in along with our distances that were given. So 10 miles was the distance traveled downstream, so we'll put 10 in that numerator, and then as we just figured out, the boat speed would be going b plus 4 downstream. And then we put 6 miles in for the distance traveled upstream, and divide that by the rate of speed upstream, which we figured out to be b minus 4. So notice that we have a rational expression on either side of the equal sign here, so this makes it a rational equation. And if we solve this rational equation for B, we would be able to answer the question, which is what is the boat's average rate in still water, because that's what B represents. So let's go ahead and solve this equation. So we're just going to use our usual methods for solving a rational equation that we learned in the last video. And remember that to solve a rational equation, we're going to multiply both sides by the least common denominator. And in this case, these denominators are factored completely. They don't share any common factors. So the product of those two denominators will be the least common denominator. So we'll multiply both sides by that least common denominator. And remember that when we do this, all of the fractions should become cleared from the equation. So notice on the left side that we can cross-cancel the b plus 4 factors. And then on the right side, we can cross-cancel the b minus 4 factors. So the denominators completely cancel out. So yes, indeed, our fractions are cleared. So now to simplify this more, we're going to have to multiply the b minus 4 times 10. So we're going to have to distribute 10 through the b minus 4 factor, and then also on the right side, distribute 6 through the b plus 4. So if we go ahead and do that and simplify, we end up with 10b minus 40 on the left and 6b plus 24 on the right. So now we have an equation to solve. And what kind of equation is this? Right, it's a linear equation. So to solve a linear equation, we simply need to get the variable terms to one side, constants to the other, and then divide. So if we subtract 6b from both sides and also add 40 to both sides, you should end up with 4b equals 64. Then we divide both sides by 4, and we obtain our solution, which is b equals 16. So now we're ready to answer the question, which is that the boat's rate in still water is 16 miles per hour. Alright, so now let's look at this equation in another way. Notice that this has just a single fraction on the left and a single fraction on the right, and there's no other terms. Whenever you have an equation that states that one fraction is equal to another fraction, it's called a proportion. And you may have learned about proportions in the past. And there's actually a pretty smooth method for solving proportions. And that is actually simpler than what we just did. But you'll see that we end up with the same process after the very first step. So another way to solve a proportion is that we cross-multiply to obtain two cross products. So we're going to multiply the b plus 4 times the 6 and the b minus 4 times the 10. Those products are called cross products. And what we do with those two cross products is we set them equal to each other. So the 10 times the b minus 4, that's one of the cross products. We're going to let that be equal to the 6 times the b plus 4, which is the other cross product. This may seem familiar to you. This looks very similar to what we had before. If we distribute, we end up with 10b minus 40 equals 6b plus 24. And then we subtract 6b and add 40 to both sides, just like we did before, and divide by 4. So we end up with the same answer, but we do end up with one less step. So I just wanted to make sure that you saw another way to solve a proportion. And again, a proportion has just a single fraction on the left and a single fraction on the right, no other terms. So if you end up with a rational equation that's a simple proportion, you can use this method to solve it. Okay, so now let's look at another type of equation or type of problem that can be solved with a rational equation. These type of equations we're going to look at next are called work rate problems. And so a work rate, by definition, is how much work is completed divided by the time that it takes to complete that work. So when two or more individuals are working together to complete a job, their work rate when they work together is equal to the sum of their individual work rates if they were working alone. So this says that if individual number 1's work rate working alone, if we took that work rate and add that to individual number 2's work rate as if they were working alone, and add them together, that sum will give us the work rate of individual number 1 and number 2 working together to complete that same job. So this is a relationship that we're going to be using, and each of these work rates can be determined using this initial definition up here in the blue by taking how much work is completed and dividing it by the time that it takes to complete that work. Okay, so let's look at an example. Here we have pipe number 1 can fill a pool with water in 4 hours, and pipe number 2 can fill the same pool with water in 6 hours. And what we want to know is how long will it take to fill the pool with water if both pipes are used to fill the pool. So if we let both pipes fill the pool at the same time, how long would that take? So let's think about their work rates. Remember that if we take pipe number 1's work rate as if it was filled the pool all by itself, and we add that to pipe number 2's work rate as if that pipe was filling the pool all by itself, and we add those together, that'll equal the work rate of the 2 pipes working together. So for each of those work rates, those 3 work rates that we're going to be using here to write our equation, again, we're going to use that definition of work rate, which is taking how much work is completed, which for this problem is just going to be 1 pool that's being filled, and divided by the time it takes to complete that task. So let's look at pipe number 1's work rate using this definition here. So for pipe number 1, it can fill 1 pool, so that's how much work is completed, in 4 hours. So we put 4 hours on the bottom. That's the time it takes to complete that task. Then for pipe number 2 can fill 1 pool in 6 hours. So how much work is 1 pool divided by how long it takes, which is 6 hours. And then the work rate together, is still filling 1 pool, but we don't know how long it's going to take for both pipes to work together. So we're going to let a variable represent that amount of time. So we'll have 1 pool on the top and X hours in the denominator for how long it takes to fill that pool. And then of course if we add these 2 individual rates together, it will be equal to the work rate of the 2 pipes working at the same time. So that will give us the rational equation 1 over 4 plus 1 over 6 is equal to 1 over x. So this is a rational equation. Of course, it's not a simple proportion, so we're going to have to use our usual techniques for solving rational equations. Okay, so let's solve this equation. And in order to do that, we're going to find the least common denominator of all the fractions. So if you think about that, you should come up with a least common denominator of 12x. And what we do with that least common denominator, again, is multiply both sides of the equation by that LCD. On the left side, we're going to have to distribute because there's more than one term. So that's going to look like 12x times the 1/4 plus 12x times the 1/6 equals 12x times the 1 over x. Now, when we do this, we should be clearing all the fractions. So notice that with the 12x times the 1/4, 4 and 12 have a common factor of 4. So the 4 goes away and 4 goes into 12 3 times. So we're left with a 3 there. Then with the 12x times the 1/6, 6 and 12 have a common factor of 6. So the 6 is going to cancel and the 12 is going to become a 2. Or you could think of it as 12 divided by 6 is equal to 2. And then on the right side, we have the x's that are going to cross cancel. So all the denominators, notice, are canceling, which means all the fractions are getting cleared. And now if we simplify what's left, we have 3 times x times 1 for the first term, and 2 times x times 1 for the second term. So that'll be 3x plus 2x. And then on the right side, we have 1 times 12. So that'll just be 12. Now this is a nice linear equation, so We can combine like terms to get 5x equals 12, and then divide both sides by 5 to obtain our solution, which is 12 divided by 5, or 2.4. You could write that as 2 4/10 or 2 2/5 if you simplify that fraction. That's how long it will take for both pipes to fill the pool. So it will take 2.4 hours for both pipes to fill up the pool.